Hey guys, thanks for joining me on this video. GCode is very popular machine code. You can look it up. It's used in laser cutters, CNC machines for milling, these kinds of things. So what the purpose of this tutorial is to just look how the NURBS curve can be translated into the instruction set for machine. And if you play the script, you see that you find the list of instructions for X, Y, Z coordinates on each point that you also see in the preview. Sorry. So just briefly, you can find this example here in the newbie category. It's a very simple example. It doesn't use also advanced G-code instruction sets. It's just creating the linear movement instructions that you can copy paste to some application and see how that looks like. But the script itself begins by creating the NURBS curve through those 5 points, and we assign the points or the curve to the variable curve for G-code, and that's it. It's the curve itself. And here in this part, the more important thing is happening. Here we create also the points on that curve, and BitByBit allows you to tessellate the curve, which means based on this tolerance, it will create more or less points on different parts of the curve. And we need in curves more points on more curvy areas, and we need less points on the straight areas. So if you will go and see into this curve, you see that there are not so many points here because it's basically a straight segment. And whenever we have a bigger curvature, it will create more points. Also here you see that it needs more precision, so it creates more points. That's quite nice because it optimizes the instructions, so you don't have too many points. You have just the points that you need to express your curve in machine kind of way. Machines travel from point to point usually, or at least that's what they are good at. Some are really advanced, they can even interpret the NURBS data, but usually the more primitive ones will just travel from point to point. That's very important to be able to construct those points in BitByBit. That's how you can draw quite complex drawings and still get the optimized instructions. This code is creating the points from the curve, and those points is all we need. We need to basically read the XYZ coordinates of each point and translate that to the instruction set. So it's not a complicated script in that sense, but still it involves some programming. In this part of the script, so these three components, they just initiate some settings or initiate the variables to the right state before we enter into this iteration loop that goes through all the points. And we need two things. So one thing is this G-code text variable, which is in the beginning just an empty list, and that is used for as a sort of container for lines of the instructions. And this G-code tags variable is used to visualize the tags in space. So it's not really needed for the instructions. We could just use this G-code text for it, but we also want to visualize those points in the instructions. And that's why we use this additional container, which is also in the beginning just empty. And we add one element into the G-code text, and that's generated with BitByBit.dev comment. which you also see if you run the script. You see it as the first line in the text to save category. And that's how it works. So you enter the line of text into this variable, into this container, and it appears in the instructions. We could even do additional one, like G-code text. We can add another one, like you guys are great, and you will see that now it also appears in the instruction set here. So what we should do is, for the instructions, we need to go through each single point that we generated in the tessellation process, and with that we need to read the coordinates of x, y, and z and put those into the same G-code text container. And that's what is happening in this for each loop. You see that it says what it does. It's for each item curve point in the list of curve points, it does this sort of operation. And few things are happening here. Because we know curve point in this instance, we know how to ask for the x coordinate and y coordinate and z coordinate. But we also know that having this point, we can tag it with the text in space. And this is the part which does the tagging. If you look in this 3D model, the tags themselves are floating a bit higher, and that's why you see a bit more complicated structures here. They sort of offset the text a bit higher of the curve, so it's not exactly on the point itself. But just to go and focus more on this part of code, well, G-code needs to begin the first line with G1, and that's for meant for linear movement. There are many things in G-code, many standards that you can follow, but this is the very simple one, and that's you see that the first line of G-code begins with G1, and then you don't see it anymore because it means that you just go in this G1 type of movement for all the points. And that's very simple. I didn't want to go and involve myself into more complicated G-code data structures, but that's it. But because it is being added only on the first for the first point, I need to know that and tell the script to only apply G1x to the first line and not the others. So this is what happens in this if statement, and it says if the point is not the first point in the list, then set the x line to just x, and otherwise is just G1x. So that means that for the first line it will be G1x, and for all the rest it will just be x. This is quite simple logic, but still it's good to understand what is happening here. And the rest is quite straightforward. The only thing that needs to be explained is that you see that here we create the text with multiple items of text, and it's the x line that goes into the first item, and then the x needs to be so if we run it, you see that it's always how the standard works is that you see you have this G1x or x followed with the coordinate itself of the x. So, and then you have y, and then you have the number for y coordinate, and so forth. So this is the code that is responsible for it. You see that we add x line, and that's G1x or x, and then we add to it the rounded number of x coordinate of the point. So that's the and we round it to 3 decimal places, just to be not too precise, but precise enough for the machine. And that is followed by the y, so the space character y, and then this is the magic trick. This is so you see that this is a y coordinate, but we use z coordinate, and it's a bit tricky to understand why that is. I will explain that now. So basically, there's this fundamental difference sometimes in applications. Some applications use y for up vector, and some applications use z for up vector. Machines tend to use z for the up vector, and BitByBit uses y for up vector as a standard, and that's why you have to remember to sort of convert the right coordinate to the right up vector. So here we choose to use z of the point for y vector and y for the z vector. That's just a bit irritating. I understand it. It's not very clear why that is, but trust me, you will see this kinds of conversions from time to time happening in CAD and CAM applications. So I hope you are not discouraged by that. It's just a sort of notation thing. And so when we create this text with multiple items, we assign it to the variable line text. And line text is basically what the variable that goes into the GCode text list. And you see that in this last line, we just added as a last item into the list of GCode text. And GCode text is just a container of multiple lines that go into the instructions. And GCode tags also use the same line text component on a bit different point, but still it reflects the same text that was generated here in the pink color. So that's it. That's basically how it all works. And then when this iteration goes through all the points, we continue and we say preview text and save to file, and we just give it this GCode text list, and it opens up. It's this component is this component is responsible for previewing that this dialog, which also allows you to look at the GCode that was generated, but also you can choose to save this file to the computer. So the file name will be curve and the extension will be NC for numeric control. And if we save it, you see that the file gets saved as curve1.nc because I already saved one file. So now it's just popping up this number. So I hope that's clear. And we have a few more components here that are just responsible for drawing the tags in space. So here we created the tags and added them to the list. And here we are saying, okay, because we now have all these tags generated, we just need to draw them, and we draw them, and we can draw the points of curves. These are gray points, you see. I can make them white if you want to. And we draw the curve also in space as white. So if I run the script now, you see that I open this dialog again, and the points are now white in there. And that's it. We went through this whole script. I hope it's quite clear. One more thing that I'll do is we generated the real G-code. It's not complicated, but it's still valid G-code. And to just prove that to you, I don't have a machine to use it in, but we can try it out. There are many G-code viewers and G-code simulators where you can see what happens. So I just opened this NC viewer from Sander Luciano, I think that's the author, I hope. And I hope I pronounce his name correct. But you can copy paste that code in here and you can plot it. So you see that you just got my curve in here. I think you can also rotate. So this is no BitByBit, it's a different kind of application, but you can also click this play button, I hope, or let's see what happens. Plot. Maybe the comments are not. Oh yeah, so now I see the milling bit, and I think I can play it. So you see now it simulates line by line how the mill bit will travel through this point. And this tool is just an abstraction. Of course, it can be a laser, it can be a milling bit. There are many kinds of machines, but this is just illustrating a bit how this tool will travel through the path. So I think now I explained the whole G-code thing. Thanks for watching. Please do subscribe on YouTube if you liked this video, and see you in the other videos. Thanks guys, bye.